Hi, I am Sujon. This is my channel. Try to understand mathematics. Please like, comment, and share my videos and subscribe my channel. Welcome. This is my channel. Try to understand mathematics. Today's topic is Rolle's theorem and its application. First, know what is Rolle's theorem. Let f of x be a real valued function in closed interval ab such that first condition is f of x is continuous in the closed interval ab. Second condition is f of x is derivable in the open interval ab. And third and last condition is f of a equal to f of b. Then rules say that then there exists at least one point c belongs to in the open interval ab such that f dash c equal to 0. That is, if function f of x, a real valued function in the closed interval, is if it is continuous and derivable in the open interval ab, and their functional value at a and b point are equal, then there exists at least one point c in the open interval ab such that f dash c equal to 0. That means derivative of that point is equal to 0. We know about geometry, what is its geometric interpretation. We know derivative of a function at a point is a slope of a tangent of this function of a graph at this point. What means that is tangent equation at that point. So f dash c means slope of the tangent at that point. X equal to c is 0. That is, tangent equation is parallel to x-axis. If we draw a curve, then we see this figure. What is its geometric meaning? Suppose this is curve f of x, this is x-axis, y-axis. Suppose that point is a and that point is b. Here we see here this function is continuous as there is no gap between this curve, and this function is derivative as there is no sharp edge. So, and here third condition is functional value at a point and b point are same. So by Rolle's theorem there exists at least one point c between ab, their derivative at that point is 0. Here this point, suppose c in the open interval ab, here f dash c equal to 0. That is, here if we this tangent is parallel to x-axis. Okay, again if we draw another curve, suppose this curve is in that format. Suppose their functional value at a point and b point are same. and this curve is continuous. As we know from the definition of continuous curve, without lifting pen, if we draw a curve, that curve is continuous curve. So this curve is continuous curve, and this curve is also has no sharp edge. So they are, sorry, here this figure also same. If we draw another picture, if suppose this type of, here at that point a and b, their functional value are same, and this point c, if we draw tangent, that is parallel to x-axis. Again, if we draw another line, suppose this kind of, here at that point a and at that point b, their functional value are same, and this point, if we draw tangent, this tangent is parallel to x-axis. Okay, now we saw about its application. Suppose let us take an example. F of x equal to x into x minus 1 whole square in the closed interval 0 to 1. If we simplify this, this will be x into x square minus 2x plus 1, that is x cube minus 2x square plus x. Okay, we know every polynomial function is continuous in the interval anywhere, any real line. Again, polynomial curve is also derivable. Okay, so this function, our by Rolle's theorem, first condition is f of x is continuous, so this function is continuous. Again, this also polynomial curves mean this is derivable in open interval 0 to 1. And thirdly, functional value at 0, this will be 0, and if we put x equal to 1, then functional value f of 1, that also 0. So three conditions are satisfied. Now we see about f dash c. Here if we find derivative this function, this will be 3x square minus 4x plus c. By Rolle's theorem, f dash c equal to 0. That means f dash c equal to 0, that means 3c square minus 4c plus 1 equal to 0. That means if by Sidharacharya, this will be minus b plus 1, b square means 16 minus 12 by 6. So this value will be 1, either 1 by 2, sorry, 2 by 6 means 1 by 3. Here 1 by 3 point lie between 0 to 1. Here by Rolle's theorem there exists at least one point, so we here get this point c. So this function is f. This function verified for Rolle's theorem. Again, if we consider another example, suppose f of x equal to x minus 1 into x minus 2 into x minus 3 in the closed interval 1 to 3. This function, if we simplify, this will becomes x cube minus 6x square plus 11x minus 6. Again this is polynomial function, so this is continuous, derivable, and if we put f equal to 1, this is 0, so this will be 0, and if we put f equal to x equal to 3, so this term is 0, so f of 3 means 0. So third condition also satisfied. By similar way we can find here f dot c equal to 0, and here we find c equal to something that belongs to 1. Okay, let us take another example. If we take f of x equal to sine square x, we know if a function f of x is, we know sin x is always continuous in 0 to pi, so f of x is here sine square x, that means sin x whole square. So we know that f of x is continuous, then f of x into f of x function is also continuous. So our this function also continuous. Again we know sin x is derivable function in the interval 0 to pi, so this also derivative exist this function in 0 to pi. And here f of 0 is 0 and f of pi also 0. Here by similar way we can see this function also satisfy Rolle's theorem. Okay, if we take another by similar way, we can prove that f of x equal to cos square x in 0 to pi is also satisfy Rolle's theorem. Okay, if we take f of x equal to e to the power minus x sin x in 0 to pi, so this function e to the power x function is continuous and sin x function is also continuous, so their product also continuous in the interval 0 to pi. Again this function is derivative exist in open interval 0 to pi, and sin x also has derivative exist in the open interval 0 to pi, so this function product function must be derivative also exist. And here f of 0 is that function value is 0, and if we put x equal to pi, then f of pi is also 0, so third condition also satisfied. So if we derivative this function, this becomes e to the power x cos x minus e to the power x cos sin x. So by Rolle's theorem, f dash c equal to 0. So if we put here e to the power minus c cos x cos c equal to e to the power minus c sin c. So e to the power minus c is non-zero, so from here we see tan c equal to 1. That means tan c, if we take pi by 4, this will be c equal to pi by 4. This pi by 4 value belongs to 0 to pi, so this function also verified for Rolle's theorem. Okay, let us take another problem. Suppose we take function f of x equal to 1 minus square root of 3x square in the interval minus 1 to 1. Okay, so if we derivative of this term, so if we simplify this, this will be 1 minus x to the power 2 by 3. If we derivative of this term, that is f dash x will be minus 2 by 3 into x to the power minus 1 by 3, that is minus 2 by 3 into x to the power 1 by 3. Here if we put here x equal to 0, here at x equal to 0, f dash x does not exist. So at x equal to 0, fx is not derivable. So our second condition for Rolle application, that fx is derivative, fx must has exist its derivatives in the open interval 1 minus 1 comma 1, but here we see here x equal to 0 point function f of x has no derivative, so this is not applicable for Rolle's theorem. Let us take another problem. If we take f of x equal to tan x in the interval 0 to pi, so if we draw this figure, this will be this is pi by 2, this is pi, This is tan x curve in the interval 0 to, we know from the definition of continuous curve that if we draw a curve without lifting a pen, that curve is continuous. But for or draw tan x curve, we here or first draw this line and this, so this function is not continuous. Continuous at pi by 2, as when x tends to pi by 2 minus that function value will be plus infinity, and if we take x equal to pi by 2 plus this, then tan x value will be minus negative. So fx is not continuous at x equal to pi by 2. So this function is not applicable for Rolle's theorem. If we take another example, f of x equal to modulus of this x minus 1 in the open interval 0, close interval 0 to 2. Then if we simplify this function, this will be x minus 1 if x greater than 1, and this will be minus x plus 1 if x is less than 1. So here if we draw this curve, so this becomes in this here 1, so this is curve. Here this curve f of x function is continuous, as we can draw this curve without lifting pen again from so this is continuous. But here at x equal to 1 point there is a sharp edge. That means this function does not exist its derivative at that point, so is not differentiable at point x equal to 1. So this function is not applicable for Rolle's theorem. Let us take another example. If we take f of x equal to mod of sin x in the interval minus pi to pi, if we draw this curve, this is 1, so this will be at that, but here function value, this is sine curve, but here function f of x is mod sin x. That means every value is it's positive, so this is not, so this will be here, so this will be original figure, so this will be reflection, so sin x mod sin x curve will be in this way, that is 0, that is pi by 2, that is minus pi by 2, that is minus pi, that is pi. So mod sin x curve is in figure this. So from this figure we easily say that f of x is continuous, as we can draw this figure without lifting this pen. Okay, again this function has derivative not exist at that point, as there is at x equal to 0 point there is a sharp edge, so that means there this point has infinite tangent. We know that if a function f of x function, suppose at any point that derivative also exists, if that point if exists there is only unique tangent, but if we draw this surface there is infinite tangent, so at that point f of x is not derivative exist. So at x equal to 0 mod sin x is not derivable. Okay, so this is not applicable for Rolle's theorem. Okay, let us take last example, if we take f of x equal to sine mod x in the interval minus pi to pi. So if we draw this figure, so this becomes in that way, and then as usual, okay, so this is minus pi, this is pi, this is pi by 2, this is minus pi. From this interval we see mod of sine x, sine mod x is continuous as there is no gap anywhere, so this function is continuous, and we see at that point there is a surface, that means at that point there is infinite number of tangent. So at x equal to 0 sine mod x is not derivable. Okay, so here by for Rolle's application their second condition does not satisfied, so this function is also not satisfied Rolle's application. Okay, thank you.